Okay, so we're going to be looking here at talking about just some basic biomechanics. Most of these concepts we covered in previous courses, particularly the 240 course. So what I would encourage you to do, even though we're not covering the entire chapter, if for some reason there's maybe something you want to review in chapter 2 in the Essentials textbook, you could maybe get a little bit better picture if maybe something's unclear after this, because I'm going to basically review some of the general concepts that we're going to look at, and then we'll be working with some of these in class as well. So make sure after having gone through it, like I said, you can use that chapter in your textbook for the particular areas that we look at, and we'll kind of move on from there. So what we're going to be looking at is looking at levers and talking about the different classes of levers and the significance of them with biomechanics, particularly the anatomical aspects of that. We're going to look at the planes of motion and the axes of motion, and kind of discuss those again just briefly. We're going to work with them a little bit more in class, and kind of talk about those as well. Newton's laws, which is something that we're going to look at in addition to this, human strength and power, and just kind of talk about joint motions in general. Okay, so the first concept we're going to look at and review is a lever. So in order to kind of understand levers, you have to kind of know the parts. So first of all, as we'll be discussing, there's 3 classes of levers. We'll talk about, how those different classes of levers are set up and kind of what's the point of different types of levers. So first, just to kind of define what a lever is. So a lever is any type of rigid or semi-rigid body. When a force gets put through it and it doesn't pass through the pivot point, it's going to basically exert a rotational force on another object. So for instance, if we look at most of the joints, really all the joints in the body that are freely movable, they all work through the idea of a lever. Okay, so the muscles are going to clearly pull on the bones, and it's going to create a rotational force or a torque through the different joints. So in looking at that, we have to look at the different parts of a lever. So as we said, it's a body where the force, that when a force goes through it, doesn't act at the pivot point, and that pivot point's the fulcrum. Okay, so the fulcrum is going to be the pivot point of the lever. And on the upcoming slides, again, we have some graphic representations of kind of just what a lever would look like. It would also kind of help in the textbook. So again, even though we're not necessarily covering all of chapter 2 in the Essentials textbook, chapter 2 really right at the beginning kind of discusses some of the stuff with a lever too. So it might just kind of help. It's not like an assigned reading per se, but that can also kind of help some of your understanding too. So the fulcrum is kind of the pivot point of the lever, and then you have 2 different arms. You have an effort arm or a force arm, and in the case of the body, that's where the muscle's going to be working through. And then you have the resistance arm, and the resistance arm is going to basically be the force that acts on the opposite end that basically that has to get moved. So again, weights, gravity, it could be the weight of the limb when the joint's moving through the range of motion. So those are the 3 primary points. So now in the upcoming slides, again, as I said, we have 3 classes of levers, and we're going to be looking at those 3 classes of levers, kind of just discussing the general setup. When we meet up in class, we're going to go through some activities and kind of review how we can apply these different levers, both to the body and just so you can see conceptually how they work through, just some of the things in life, because there's also things that kind of in our daily lives also kind of function as levers as well. Okay, so when we're looking at our different classes of levers, we have our first class lever, and we're going to do this with each one of the individual classes. The other thing we will look at is the concept of mechanical advantage as we're looking at the different classes of lever. So when you have a first class lever, you can see here you have your effort and resistance. Okay, so when you look at mechanical advantage, so anytime you're calculating the mechanical advantage of the lever, it's the ratio of the effort or force arm to the resistance arm. Okay, so basically if you're measuring it, you go from the end of the effort arm to the fulcrum, and then you measure the end of the resistance arm to the fulcrum. And that tells you whether you have what your mechanical advantage is. So anytime you have a mechanical advantage greater than 1, meaning that this arm would be longer, the force that has to be applied is going to be less than what the resistance force is to create movement. Okay, so in other words, if this arm happened to be longer than this arm, if I were to have a weight on here, so let's just say, we had a weight, a box. Sorry, it didn't quite land on there. Let's say we had a box on here and we wanted to push down on this effort arm and lift this box. If this effort arm were longer, okay, which on this drawing they look to be about the same, but let's pretend it's longer, the amount of force you would have to apply would have to be less than whatever that box would weigh. In other words, you would have a mechanical advantage greater than 1, okay? If, in the case the resistance arm is longer, you have to apply more force than what's required, okay? So, as you see with a first class lever, okay, you could have a mechanical advantage greater than 1 if the effort arm is longer, or you could have a mechanical advantage of less than 1 if the resistance arm is longer, okay? You could also be in a situation where it's just right in the middle. And typically what you see with first class levers, usually the goal of a first class lever is to create some sort of balance in many instances, which would make sense. You have your fulcrum right in the middle. But in the case of a first class lever, you can have a mechanical advantage of greater than 1 or less than 1, depending upon which one of the arms is actually longer. Okay, so that's your first class lever. Okay, so again, anytime you have the force, the effort force, and the resistance force on opposite sides of the fulcrum, that's a first class lever. All right, now we'll look at a second class lever. So in the case of a second class lever, so you notice we have our fulcrum up there, the little triangles all the way on the one side. So in this case, now we have a situation where the fulcrum is all the way to the end, and your effort and resistance kind of line up this way, okay? So now when you measure the distance, so if we were to try to figure out the mechanical advantage of this particular lever, we have to measure remember we said it's going to be the ratio of the effort or the force arm to the distance of the resistance arm, okay? So here's our effort or our force arm if we're measuring the distance. So if we're measuring the distance, we go to the end of the arm to the fulcrum, okay? So that's the distance of our effort arm. If we're measuring the resistance arm, we go from here to here, okay? So if we were to look at that, in the case of a class 2 lever, the effort arm or the force arm is always longer. So what this means is in a second class lever, your mechanical advantage is always greater than 1. So what that means is your force that gets applied, okay? So in other words, if, let's go back to our example we did in the first slide. So if let's just say again, here's our weight, okay? So our box is there. So if we push down on this, or here, nope, we don't want to push down, we want to lift up. So if we were to lift this, so if this was on the ground and we wanted to lift this, we would actually have to put less force than what the weight would be in order to do it, okay? Because since we have a mechanical advantage of greater than 1, okay? So anytime the force arm is longer, which is always the case in a class 2 lever, you don't have to apply as much force to the resistance in order to create movement, okay? That's your second class lever, all right? So again, effort or the force arm is longer and is all the way at the end, and your resistance arm, your resistance is in the middle, okay, and is the shorter of the two. So when you're measuring, again, you go from the effort to the fulcrum and the resistance of the fulcrum. The effort's longer, therefore you do not have to provide as much force to create movement. Okay, now we have our third class lever. Okay, so again, the fulcrum is going to be on the end. So the pivot point is going to be at the end. And the resistance arm and the effort arm flip. Okay, so this is a lever again. So they're both going to be acting on the same side. So both the second and third class lever, the force arm and the resistance arm, okay, or the effort arm and the resistance arm, all act on the same side. However, in this case, so again, if we were to measure again, so here's our effort arm, here's the resistance arm. So if you're looking at that, which one's longer? Okay, if you're saying to yourself, well, the resistance arm is longer, you are correct. Which means that in the case of the third class lever, you always have a mechanical advantage less than one. So what this means in the case of, and we'll just talk about this regarding the anatomy because it'll probably make it easier, the muscle force always has to be greater than the resistive force, okay? So in order to produce torque or rotational force, the resistance has to be greater than the actual than the resistance, because your effort is coming is your effort arm is going to be much shorter. Your mechanical advantage is going to be less than one. So in the case here, now you're saying to yourself, well, that doesn't seem to be very efficient because you have to produce disproportionately more force because of that effort arm being shorter, and you'd be right. However, even though the third class lever doesn't favor force production, it does favor movement, okay? So it favors movement, ergo there are situations where a third class lever would be relevant as far as the mechanical advantage is concerned. So to review quick, class 1 lever, okay, so we went through our first, second, and third class levers. In the first class lever, the effort arm and the resistance arm operate on opposite sides of the fulcrum. In both the second and third class lever, the effort and resistance arm operate on the same side. In the case of a second class lever, the mechanical advantage is always greater than 1. In the case of a third class lever, the mechanical advantage is always less than 1, okay? In the case of a second class lever, the force required is smaller than the resistive force. In a third class lever, the force required has to be greater than the resistance force in order to create movement, okay? So that's going to be an important point. So now when we kind of look at different, again, we're going to do some activities with this in class. One of the things I want to look at, there's going to be 2 discussion questions that I want you to look at. Okay, so the first discussion question, so make note of this because I'm gonna post this in Canvas and I want you to answer this. The first thing is what class of lever is the most common type in the body? Okay, so that's going to be the first question I want you to answer for me in that. Okay, and that's going to be posted on Canvas. So what class of lever is the most common? So in other words, if we look at all the joints in the body and how muscles act on them, which one is the most common? Okay, so is it the first, the second, or the third class lever? Okay, you could use the textbook to read. It'll probably kind of tell you in there, but you could think anatomically what would be the most common class of lever. All right, when we're looking at the body. Another concept that we're going to look at in review are the planes of motion. Okay, so in looking at the planes of motion, so this is something that we talked about in 240. We also talk about this a little bit in functional anatomy. So the picture that you're seeing here are the different planes of motion. So you have the sagittal plane, which cuts the body into right and left halves. You have the frontal plane, which cuts the body into front and back. And you have the transverse plane, which cuts the body into top and bottom. Okay. Now the key with movement is that movement always occurs through a plane. So we're always going to be talking about, we'll talk about the planes and we'll talk about the axes of motion. Okay. Movement goes through a plane and around an axis. Okay. So when we're talking about, like, just for instance, shoulder abduction. Okay. So when you abduct your shoulder, there's a plane that moves through and there's an axis that it rotates around. Okay, so those are the planes. If we look at the axes of motion, so the axes of motion go perpendicular to the planes. Okay, so you have the anterior posterior axis, also known as the sagittal axis, runs perpendicular to the frontal plane. You have the medial lateral axis, which runs perpendicular to the sagittal plane. It's also known as the frontal, so make sure you're familiar with both terms. So it's a little weird. So you have the sagittal axis runs perpendicular to the frontal plane. The frontal axis runs perpendicular to the sagittal plane, but know both terms. And the anterior, posterior, medial, lateral, that's just telling you how it runs. So again, it runs perpendicular to those. And then the longitudinal axis, which runs perpendicular to the transverse plane. Okay, so in looking at this, okay, and here's something to remember, so to make this real easy. So if we look up here, so anytime you have movement, so remember, we always said movement moves through a plane. So if you have a movement that moves through the frontal plane, it always rotates around the anterior, posterior, or the sagittal axis. So in other words, these concepts are paired. Okay, anytime you have something that moves through the sagittal plane, okay, so a movement that goes through the sagittal plane always moves through the medial lateral axis. If you have any movement that goes through the transverse plane, always runs through the longitudinal axis. Okay, so those concepts are there as far as movement. So this is just kind of how we look at and kind of describe movement. So be thinking about some examples of those. Again, we're going to work with this concept a little bit more in class, but hopefully you're familiar with these concepts and as it relates to the planes and axes. The key being is these are always paired up, but make sure you can kind of visually see them so that when we kind of work through some stuff in class, we're able to kind of know this, and it's kind of a base foundation for just kind of like seeing basic movement. Okay, so that takes us into looking at Newton's laws. Okay, so we're going to go through Newton's laws and just kind of discuss them in general. They do kind of serve as some good foundational information in as far as some of our basics, physics, and force applications are concerned. So the first law is the law of inertia. Okay, so first we have to define what inertia is. So inertia is a body's resistance to movement, or an object's resistance to movement. Okay, so all objects possess inertia. However much inertia it has is kind of based upon the size of the object, how much mass it has, things of that nature. But all objects possess inertia. Okay, so when we look at the law of inertia, a body will remain at rest or at constant velocity unless acted on by an external force that changes the state. Okay, so let's take an example, for instance. So if we have a glass of water and we put it on the table, okay, that glass of water is going to remain as it is unless something happens to it. So if somebody were to come and bump the glass of water, well, clearly now something will change as it relates to the glass of water. It's going to knock over and spill or shift on the table depending upon how hard it gets hit. So a body at rest will remain at rest, or a motionless object will remain motionless, okay, unless there is a net force acting on it. So in the example that I just gave with the glass of water, that glass of water pretty much is just going to sit there unless, again, somebody picks it up, bumps it, whatever. But that's essentially what's going to happen, okay? Now, when a body is traveling at constant velocity, the enactment of inertia is not so obvious because external factors do not act to reduce velocity. So basically the law of inertia, if you were to sum it up, is an object in motion will remain in motion, an object at rest will stay at rest unless acted on by an outside force, okay? The more inertia that an object possesses, the harder it is to effectively create motion from or move, or the harder it is to stop, okay? So that's what the first one of Newton's laws, or Newton's first law, states. So again, inertia is a actual quality that something can possess, and that is its ability to resist movement. And again, a body at rest will remain at rest, or a body in motion will remain in motion unless acted on by an outside force. Okay, so that moves us on to Newton's second law. Okay, so again, as we're going through these laws, you want to kind of keep in mind the important aspects of those different laws. Okay, so then the first law was the law of inertia. And again, inertia is basically the property of a body that resists changes in it, whether that's making it more difficult to move and or making it more difficult to stop moving once it's already moving. The law of acceleration, what we're dealing with here is, so the law of acceleration states that a force applied to a body causes an acceleration of that body of a magnitude proportional to the force in the direction of the force and inversely proportional to the body's mass. Okay, so the second law of motion, a key sort of aspect of this is the formula force is equal to mass times acceleration. So really, more simply stated, if you even want, a greater force is required to move or stop the motion of a larger mass than a smaller one. Okay, so there's some similar properties to here between the first and second law. The second law just deals more directly with the amount of forces and how it interacts with the body. So again, when a ball is thrown, kicked, or struck with an implement, it travels in the direction in the line of the applied force. The heavier the ball would be, in this instance, the more force would have to be applied to it, okay? So, if we're looking at the soccer ball, you need to apply a certain amount of force to the soccer ball in order to get it to move a specific distance, okay? And it'll move in the direction of the applied force, okay? So basically here you look at these three things. So whereas the first law dealt with the law of inertia, this is dealing with the law of acceleration. Again, force equals mass times acceleration, kind of being the key aspect related to the second law of motion. Okay, and the last law is the law of reaction, or you might have heard it also called the law of action-reaction. So this action states that for every action, there is an equal and opposite reaction, okay? So that basically means whenever one body applies to a force to another, the second body provides an equal force in the exact opposite direction with equal magnitude as the first body, okay? So one body or object provides the action, the other one provides the reaction force, okay? So when one body exerts on a second, it's gonna act in equal magnitude and opposite direction of the first, okay? So a real simple example you could look at here is when you jump, right? When you jump, your body exerts a force into the ground, and the ground will put a force back up at you, allowing you to jump, Okay, that's the law of action reaction. Okay, when you sprint, your foot strikes the ground, earth puts force back up on the body when you're sprinting. Okay, you know, if you have two football linemen and they push into each other and neither moves, they're basically abiding by the same thing. So let's say you have an offensive and a defensive lineman, they're both producing the same amount of force. Well, it basically means neither one of them is going to move. The only way one of them is going to move is if one manages to overtake the other. Okay, so that's the law of action reaction. All right, so those are Newton's three laws. Again, the law of inertia. So again, the key sort of factor there being the idea of inertia. The law of acceleration, that concept of force equals mass times acceleration, and then the law of action reaction. Okay, so those are Newton's three laws. Again, we'll kind of go through and work those a little bit more in class and see that everyone sees the application of those. And then we're just going to go through some basic definitions of human strength and power. So the idea of acceleration. So acceleration is basically the change in velocity per unit time. Okay, so as something's starting to speed up. So for instance, when we look at a sprint, you know, take like a sprint in track and field, 100-meter sprint. So for the first typically upwards to 60 meters, the racers are usually increasing in velocity, and that's your acceleration, okay? So acceleration is a change in velocity per unit time. We look at the idea of strength. So again, we're going to talk about strength and we're going to talk about power. Strength is the maximal force that a muscle or muscle group can generate at a specified velocity. So strength just typically looks at the amount of force that a muscle is going to generate. Okay, and that's a key point when we're looking at the difference between strength and power, because we're going to talk about power next. We're going to talk about workforce, then we're going to talk about power. Work is the force times distance. So basically, it's the product of the force exerted on the object and the distance in which it's moved. And then power is work divided by time, or force times velocity. So power kind of has two different equations at play here. Work divided by time, and also note force times velocity. So a key thing here to differentiate is between strength and power. Again, not the same thing. Okay, strength just strictly deals with the amount of force. Okay, it has velocity here in the definition at a specified velocity. The actual velocity doesn't really come into play until we talk about power. Power is force times velocity. Okay, so strength and power are certainly related qualities, but they're different in as far as their application. So again, strength is strictly force. Power is force times velocity, or work divided by time. So power has a speed component directly with it that kind of affects how it's expressed. Okay, so again, four key definitions here: acceleration, strength, work, and power. Okay, and your associated definitions. So these are your learning outcomes. So again, be able to define those strength and conditioning terms. So again, being able to tell me what acceleration, strength, work, and power are. Explain and apply Newton's laws. We're going to go through some Newton's laws applications in class so that you can kind of see how they operate. Identify planes and axes of motion, and explain the classes of levers. So the other thing in addition to this that I'm going to have you do is I'm going to have you, there's going to be two discussion board points I want you to put up in Canvas. Okay, so I'm going to post the discussion board. You are simply going to answer these two things for me. Okay, number one is, what is the most common lever in the body? So in other words, anatomically, when we look at our joints, what's the most common class of lever? The second thing I want you to do, I want you to take any motion at the body. So take a joint and a motion that occurs, and I want you to tell me what plane and what axis it occurs in. Okay? So for instance, and you could take any joint, so let's just say I use knee flexion. Okay? So if I thought of knee flexion, it's the first motion I think of. I'm going to put what plane and what axis knee flexion occurs in, okay? So those are the two things you have to do after watching this video, is go into that discussion board, answer those two, and put in your post those two things. Number one, put your whatever the most common lever is in the body, as far as which, what's the most common. If we're to look at all the joints, how the joints function as levers, what's the most common one, the first, second, or third class. And for the second one, put that for number one. Number two, put in there a joint motion, any joint motion in the body, whatever one you think of, just give me one. Tell me the plane and the axis it rotates around. Tell me the plane it moves through and the axis that it rotates around. And that concludes this. So again, we'll work through some of these things in class and do some activities with them too. But this will at least get you started. Just make sure you do that discussion board post.